Hello everyone. This is the first section of the factoring packet that we've been working on this week. The first couple pages are going to be mostly review, and then I will talk to you guys about how to do factoring and then how that works in with all the quadratic stuff we've been doing. But first of all, the first page, and really the first couple pages, are a review of some things that we do need to make sure you know in order to do the factoring section. So that's what this video is going to focus on. First thing is x-intercepts. Remember that those are where the graph crosses the x-axis. Generally there are 2 points, but you can sometimes have 1 or even 0. So where the graph crosses x-axis. And then obviously if it's a y-intercept, that's where it crosses the y-axis. So in our first 2 examples, we've got 2 of them in each, because our x-axis is this guy. So I've got, you can either write it as x equals 1, or you can write it as 1, 0, and then x equals 3 or 3, 0. They're pretty much the same thing. Same thing here. X equals 5 right there, and x equals 1. So there's our x-intercepts. Hopefully easy stuff to remember. Hopefully this is something that's become a bit more ingrained in your brain at this point. Again, noticing that every one of these x-intercepts has a y value of 0. Now that's going to be important because once we get down to the ones like this, where it's an equation and I don't have a graph to look at, that's what I'm going to use. I have to make it so that this y value is 0, which means I need to plug in something for x that's going to make it equal 0. Well, what goes in place of here? What plus 3 makes 0? In other words, what makes x plus 3 equal 0 true? Well, if I do a little algebra, I get that one of them is x equals -3. If I do the same thing with the second one, I get that x is +5. So those are my 2 x-intercepts here. Same thing here. And you can probably do this mentally. Doesn't really take too much to figure out that it's x equals 7 and x equals 6. But if you need to, feel free to write out the algebra here. Again, the reason I'm setting it equals 0 is because x-intercepts have a y value of 0. All these do. Every x-intercept does. So I've got 1 at 5, 1 at -3, 1 at 6, and 1 at 7. So really what we just did is actually called the zero product property. And all that means is that if I have something times something equals 0, then both of those somethings can or should equal 0. That's really what that property is doing. So when I'm saying that each of these groups equals 0 together, that means either this equals 0 or this equals 0. And we just did these up above, so I'm just going to rewrite these in. Did this one too already. That one was done on the top part of the page. Now if you take a look over here, it's a little bit different, but really it's still the same process. I still have x plus 0 equals 0, and mentally I can kind of say to myself that that's just x equals 0. Now this one I can't do the shortcut of just taking the opposite sign, because I'm going to have to do a little bit of extra work in solving for x here. It's not just +1. I'm going to have to do some algebra, so I'll add 1 to both sides. And I get 3x equals 1, and then to get x by itself, I divide by 3, which means my second x value is x equals 1/3. So this time I got a fraction worked in there. All right. You need to try the remaining ones. That's your practice, so try those, see how you do. You can always ask for help if you're not sure. Okay. Once you've done those other ones, go ahead and watch this now. We've got two tables with two different forms of the graph. One of them's in standard form. Just regular x squared, x plus a number. And then this one on the right is called intercept form. Now we're prepping you to get ready to figure out how to go from standard to intercept. That's kind of our goal with factoring. That's the whole point of factoring, is to be able to do that. Now, we want to show you just a quick practice with these. I'm only going to do a couple of them just to show you. So I'm going to do just -1 to maybe +1. Now, really what we did in class is we had everybody take each of these and then plug them in, and we figured it out as a group. Now, what should be true is that it's the same for both groups, because remember we talked about standard and intercept form. You can kind of think like water. Water is H2O, whether it's steam or ice or liquid, whatever form of matter it's in, it's still going to be called H2O because that's always its form that it takes. Same thing here. Even though this equation has a different setup, and it's standard versus intercept, I should get the same number. So if I plug -1 into here, well, -1 squared is -1 times -1, which is +1. 6 times -1 is -6, and then +8. Okay, well, 1 minus 6 is -5, plus 8, plus 8 is 3. So let's try it over here. Same kind of process, only this time I'm plugging it into this intercept form, a little bit different math. -1 plus 2 is +1. It's going to be times the second thing. -1 plus 4 is +3. Well, 1 times 3 equals 3, and I get the same answer. Good. All right, plug in 0. I get 0 squared. 6 times 0 is 0, plus 8, it's just a regular 8. And then again, same thing here. 0 plus 2 is 2. Plug in 0 for x. 0 plus 4 is 4. And I get 8. And then again, we'll do it with 1. 1 squared is 1. 6 times 1 is 6, plus 8 is 15. +1 plus 2 is 3. +1 plus 4 is 5, so it's still 15. Okay, and go ahead and try plugging in -2 and +2. See if you get the correct thing for both of them. If you don't, then you did something wrong. So go ahead and pause there and try that. Oops. Same values. Whoops. It's a poorly written word there. Same values or points. So same exact points no matter what. Now here's the reason why this works, and I do want you to pay attention to this so you understand kind of the concept of where this comes from. You actually learned back in middle school, maybe even just as recently as last year, how to take it from intercept form to standard form, but we didn't call it those things back then. We referred to it as distributing or FOIL or rainbow method or box method, depending on what class you were in. I don't know why this just decided to go crazy. So I'm going to remind you of that. My screen stops moving. So if I have x plus 2, and I do box method here, and I multiply it times x plus 4, and you can do FOIL, you can do distribution, it doesn't matter. I'm just multiplying those two groups back together. X times x is going to be x squared. 2 times x is 2x. X times 4 is 4x. And 4 times 2 is 8. So then I put it all together. And remember, these are like terms. And again, you don't have to write this down. You just need to pay attention. And if it's done correctly, I should get the standard form of the problem, which if I check up here is exactly what it is. X squared plus 6x plus 8. Okay, so that was what distributing did back then. We're going to teach you factoring, which will take you from this to this problem. One last thing we have to review before we get to that section, though, is being able to find factors. Now, hopefully this is a super, super easy review, but as it says in a couple places, it's really, really essential that you know how to do this. Otherwise, you're not going to be able to do the next part successfully. So factors really are just, go to the definition at the bottom, a number or quantity that when multiplied with another produces a given number or polynomial. And I'll give you an example of this. So 3 times 2 gets me to 6. That means 3 and 2 are factors of 6 because they can be multiplied to get that number. So keep that in mind, that definition. You always want to start with the first factor of every number, which is 1 and itself. So 1 and 12, 1 and 30. No matter what, I'm always going to start with 1 and itself. Okay? From there, I can either use mental math or I can always plug it in on a calculator. If you're not strong with your mental math, that's fine. So try 2. Okay, well, does 2 times something make 10? Do 10 divided by 2 on your calculator if you're not sure, but you do get 5. Okay? If you are pretty good with your mental math, you know that that's the last number for 10. However, if you're not sure, do 10 divided by 3. You get a decimal. You can't put decimals on a factor tree. Or factor t, I guess. Plug in 4. That doesn't work either. You get decimals then. The next number is 5, and that's already on our chart, so don't write it in again. Okay, so then we move to 12. So we'll do 2. Well, 2 times 6 makes 12, okay? So move on to 3. Does 3 work? Yeah, 3 times 4 gets me 12. The next number I would pick would be 4, but that's already on the chart, so I'm done. I don't have to go any farther if I already have the number. Okay, so go ahead and fill in the factor charts for 30 and 24. Total, you should get, let's see, gotta count in my head. There should be 8 total numbers for 30. And there should also be 8 total numbers for 24. So keep that in mind as you go through. Go ahead and try those yourselves. See if you can correctly find the factors. If you get 8 numbers, and that's including the 1 and the 30 and the 1 and the 24, because those count as factors. If you get 8 total for each of them, then you did good, and you got them all. Okay? Feel free to ask for help if you need to. The next video will go into the new section on factoring.